are going to solve the 5th and 6th grade Kangaroo competition questions for the year 2022. Let's jump in and get started. In question number 1, 6 points are numbered as shown. Within draws two triangles, one by joining the even numbered point and one by joining the odd number points, and color the inside of one of the triangles red and the inside of the other one green. Which of the 5 options shows the picture within draws? Okay, so let's at first draw the triangle between the odd numbered points. So if we connect these 2 points, 1 and 5 and now 3, so we will obtain this green triangle. Now let's connect the points, the even number points. So here we have 4 and 6 and 2, like this. And if we compare now this figure with the answers, we will see that E is the correct answer. In question number 2, Iman rode around 5 buoys as shown. Which buoys did Iman row around it in an anti-clockwise direction? Okay. So at first here we have, let's start from here. Now we have number 1. So here in number 1, this direction is anti-clockwise. So 1 is one of the answers. Now let's continue. Here we have number 2 is clockwise, and then we have number 3, again anti-clockwise. So we have also 3. Now let's continue. Here we have number 4, which is clockwise, and number 5 is also clockwise. So just 1 and the 3 she rode around them anti-clockwise, so E is the correct answer. In question number 3, laser beams reflect in mirrors in the way shown in the picture 1. At which letter will this laser beam end in the picture 2? Okay, here let's go here and see the direction of each mirror. So here this laser beam will be reflected to this place here, to this mirror, and now to this mirror, and then to this mirror, and then to this mirror, now to this mirror, and to this mirror, now up, and now to this mirror, and now up, now to this mirror, now down, okay, and now to this mirror, okay, and then it will be reflected to this place here, and then to this place, and then to B. So B is the correct answer. Okay, now in question number 4, Cistercian numerals were used in the early 13th century as an integer from 1 to 99 can be represented by a single glyph formed by combining two of the glyphs shown below. The glyph for 24 looks like this one here, and the glyph for 81 looks like this one, and the glyph for 93 looks like this one. What does the glyph for 45 looks like? So we should look, for example, at 24. We have this 20 and 4. So if we compare this one now, we have this one as a common between both of them, and then we have this part here, and then we will have this part here. So we are combining them in one figure. So let's now see the 45. Okay, so we will have at first 40 like this, and then we will combine it with 5. So we will keep this one the same, this one, and we will add this triangle here. So I will add it like this. So the figure we obtained is the answer. So if we look and compare it with the answers, we will see that D is the correct answer. In question number 5, marbles are sold in packages of 5, 10, or 25. Tamim buys exactly 95 marbles. What is the minimum number of packages he could buy? Okay, to obtain the minimum number of packages, so we have to use or to buy the packages that contain a big amount of marbles at first. So if we assume that he bought one package that contains 25 and another one that contains 25 and another one that contains 25, so now we have 75. We cannot buy another package that contains also 25, because we will have 100 and 95 is required. So we will put here in this package 10, and then we will put again 10, because now we have 95 in total. So we need at least 5 packages, and B is the correct answer. In question number 6, ABCD is a square with side length is 10 centimeter. What is the area of the shaded part? Okay, at first, because this is a square, so the area of this square will be 10 multiplied by 10, which is equal to 100. Now, if we notice here inside the square, we have areas that are equal to each other. For example, this one is equal to this one, and this one, and this one. So and this one is equal to this one is equal to this one. So we can move some of this shaded area to this side. For example, I will move this one to here. I will shade it here. And I will move this one to here and this one to here. So what we obtained here is a triangle, this triangle. So the required area is the area of this triangle, and this triangle represents half of the area of the square, so C is the correct answer. In question number 7, in the garage shown in the picture, vehicles can only move forward or backward but cannot turn. What is the smallest number of vehicles that have to move for the black car to be able to exit the garage? Okay, here for this black car, we should move this one, which is in front of it. So now this one takes three squares, sorry, here. So this one, to move, we cannot move it backward, because here we will just have 3 here. So uh, it will still like stopping in front of this car, and this car will not be able to cross and go outside of the garage. So we should move this one forward. But to move this one forward, we should move also this one to this place, like this. And to move this one to this place, also we should move these 2 cars upward, like that. So we need 1, 2, 3, and 4 cars to move 4 cars in order to make this black car exit the carriage. So here C is the correct answer. Okay, now in question number 8, Jalila has one long string of spaghetti she needs to make smaller. Every time she breaks one piece of spaghetti, it becomes 3 pieces as shown in the picture. Which of the following numbers of pieces could she not get? Okay, so at first we have one string of spaghetti, and then she breaks it into 3 parts. And now she will break this part here, this one, also into 3 parts. So here we have 1, here we have 3. Now here we will have 1, 2, and 5. Okay, and then we will also break one of these 3 here. So we will obtain like this, and we will have here 7. So if we notice here, we are obtaining odd numbers, 1, 3, 5, 7. So every time we will obtain a new odd number. So if we look at the answers, we can see that all of them are odd numbers except C, which is 20, and this one is an even number, so this one cannot be obtained, and C is the correct answer. In question number 9, Badr rearranges the 7 pieces shown to get the smallest possible 12 digits number. What are the last 3 digits of this number? Okay, so let's try and start with the smallest numbers and put them at first. So now we have 113, so we will put 113. Then we will put number 4, and then we will put 51, and then 5, and then we will put the big numbers like 67, and then 69, and then 9. So the last 3 digits in this number are 699, and A is the correct answer. In question number 10, which of the following fractions of a whole turn should the Ferris wheel turn to bring a white pod to the top? Okay, so at first let's assume we have this circle here and we have just 4 points, A, B, C, and D. Okay, now here because we have 4 points, so this one, to turn this wheel from this point, from A to B, we need just one movement here, and to C also one movement, and now here we have one movement, and here we have one movement. So to continue one cycle A, it needs 4 movements. So we have here for each one of the movements 1 out of 4. So here because we have just 4 points and 4 movements, so we have 1 over 4 for each one of the movements. Now if you look at our example, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 points, so we have 12 movements. So for each one of these pods, it needs 1 over 12 to move from one point to another. So when do we get a white pod at the top? After one movement, if this one moved just one movement clockwise or anti-clockwise, so we will obtain a white pod at top. So the correct answer is 1 over 12.